Hi there grade 11s, I hope that you are well. The purpose of this video is to help you to prepare for the trig section of your exam paper. The paper that we are going to be working through is the South Peninsula High School November 2023 paper. Let's look at 5.1.1. Here they ask us to determine the value of b. So we can see that the y value is 1, and that's the value that is your vertical value. You have the hypotenuse of 4, so we are going to say b squared is equal to 4 squared minus 1 squared, which is equal to b squared is equal to the square root of 15. Of course we know it's both the positive and negative value of 15, but because it's on the left hand side where x is negative, we say b is equal to the negative square root of 15. 5.1.2 says the A part of the question. 5.1.2a says determine tan of alpha, and that is going to be opposite over adjacent, which is 1 over negative square root 15. Let's look at B. We've got sine of negative alpha minus 180 plus cos of negative alpha. This requires for us to simplify first. It's a negative angle, so what we want to do is we want to add 360 so that our angle becomes positive, and that gives us 180 minus alpha. Cos of negative alpha is in the fourth quadrant, so it will remain cos of alpha. And what we do from here is we can go ahead and we can go to our sketch and find our values. So sine of alpha is a quarter, cos of alpha is negative square root 15 over 4, and when we simplify that, it's 1 minus the square root of 15 over 4. 5.1.3 says, without the use of a calculator, determine the values of k and m. So now we are looking at these values. And if we look at this angle, if we take that entire angle and subtract 90, we are left with this angle here. So we are going to say sine of alpha minus 90 is equal to m over 6. But you know that that's co-function. And whenever we see sine with 90 plus or minus, it's going to become cos. So that simplifies to negative cos alpha is equal to m over 6. But we go back to that first triangle. We see that cos of alpha was negative 15 over 4. So what we do is we substitute that value. So it's minus the square root of 15 over 4, and that's equal to m over 6. And what we are going to do is we are going to cross multiply, and we see that m is equal to 6 times the square root of 15 over 4, which we simplify, which is 3 square root 15 over 2. We are going to do something similar to solve for k. We are going to say cos of alpha minus 90 is equal to k over 6. And so again, it's co-function. It will be sine of alpha is equal to k over 6. And here what we do is sine of alpha in this triangle was 1 over 4. And we are going to cross multiply, and we see that k is equal to 3 over 2. Now let's look at the reduction part of the paper. Let's look at 5.2.1. This is numerical reduction. We have cos of 210 times tan of 135 degrees divided by cos of 420 degrees times the sine of negative 60. So we know that this relates to our special angles, and we are going to say cos of 180 plus 30 because we know that 30 is a special angle. We say tan of 180 minus 45, also a special angle. 420 degrees, that is bigger than a revolution. And what do we normally do in a case like this? We subtract the revolution, and the revolution is 360 degrees. And we have sine of negative 60, which is in the fourth quadrant, and it simplifies to negative sine of 60 degrees. And all we're going to do now is simplify further. That gives me negative cos of 30 degrees times negative tan of 45 degrees divided by the cos of 60 degrees times the negative sine of 60 degrees. And all we are going to do now is take our values from our special angles. That gives me negative square root 3 over 2 times negative 1 divided by a half times negative square root 3 over 2. Negative square root 3 over 2 and negative square root 3 over 2 in the denominator, they'll cancel. So I have negative 1 divided by a half, which gives me negative 2. Let's look at 5.2.2. We have cos of 90 plus theta times the sine of 180 minus theta divided by the cos of 90 degrees plus the cos of theta times the cos of 90 degrees minus the cos of theta. So immediately when you see this, you should be thinking the difference of two squares. So let's simplify the numerator. Cos of 90 plus theta becomes becomes minus sine theta. Why? Because of the cofunction rule. And sine of 180 minus theta becomes sine of theta. Cos of 90 plus theta, cos of 90 plus cos of theta times cos of 90 minus cos of theta will become cos squared of 90 minus cos squared theta. The numerator simplifies into negative sine squared theta. The denominator, cos of 90, is 0. And so that falls away. It leaves us with negative cos squared theta, and negative sine squared divided by negative cos squared is tan squared theta. Let's look at the next question. The next question is 5.3. It says if sine of 28 is equal to m, express the following in terms of m. So what's required of you here is for you to know that you need the sketch. So if they say sine of 28 is equal to m, it's expected that you know that that's m over 1. That's your opposite over your hypotenuse. So there's your opposite, there's your hypotenuse. And so you need to find the adjacent side. How do we find the adjacent side? We find the adjacent side by using Pythagoras. X squared is equal to 1 squared minus m squared, which is going to be equal to x squared is equal to 1 squared minus m squared. Once we simplify that, we see that x is equal to the square root of 1 minus m squared, which I've filled in here for x. So that side is the square root of 1 minus m squared. Now we can go and answer the questions. So let's look at 5.3.1. Sine of negative 28. Like I said to you before, with negative angles, the easiest thing to do is to put 360 in front of it. And so there we put 360 minus 28. Which quadrant is that in? It's in the fourth quadrant. And so it will simplify to negative sine of 28. And what is negative sine of 28? You can go back to your drawing and you see its opposite over hypotenuse, which is negative m over 1, which simplifies simply to negative m. 5.3.2, tan of 152 degrees. Another deduction, what we need to do is we need to look at that value of 152 and ask ourselves, how does it relate to 28? So we can see that 180 minus 28 is 152. So we simplify. In the second quadrant, tan is negative. So that will give us negative tan of 28. Go back to your drawing. That's opposite over adjacent. So it's going to be minus m over the square root of 1 minus m squared. Now let's look at this identity in question 6. Here we are going to simplify both the left hand side and the right hand side. As you can see, it's quite a lot of work, but what we are going to do is we are going to simplify step by step. So the first thing I'm going to do is I'm going to work on my left hand side. So if I look at my left hand side, I've got tan of A. Tan of A I'm going to change to sine of A over cos of A plus cos of A divided by 1 plus sine A. Now whenever we have different denominators, we must know that we need to change to the LCM. And how are we going to find the LCM? In this case, what we are going to do is multiply the denominators together, and we have cos of A times 1 plus sine A. And then what we need to do is change the numerator to accommodate the new denominator. And so that simplifies into sine of A plus sine squared A plus cos squared A. So sine squared A plus cos squared A is 1, and that gives me 1 plus sine A. My denominator is still cos A, 1 plus sine A. And what we see here is that the denominators will cancel, leaving me with 1 over cos A. Now on the right hand side, I've got cos A. Originally, it's 1 minus sine squared A. But 1 minus sine squared A, we can change the sine squared A to 1 minus cos squared A. Why do I change it? Because if I look at the numerator, I can see that we need something to cancel. So I'm going to change the 1 minus sine squared A to 1 minus cos squared A. I'm going to change the sine squared A to 1 minus cos squared A. And I see here that 1 minus 1 will cancel, and I'm left with positive cos squared A. So I'm left with cos A over cos squared A, and the cos will cancel the squared, and I'm left with 1 over cos A. And I can see that the left hand side is equal to the right hand side, and therefore my identity has now been proven. Let's look at 6.2. So when we look at the word undefined, we normally look at denominators, and the denominators cannot be equal to 0. So if we look at this particular sum, we are looking at 1 plus sine A. When we make that equal to 0, we have sine of A is equal to negative 1. And so we see that that gives me 90 plus K360. But when we look at 1 minus sine squared A, that when we make that equal to 0, we have sine squared A is equal to 1. Again, the square root of that is both positive and negative 1, and we again have A is equal to 90 plus K360. But the other thing we need to take into consideration here is that tan of theta is also undefined. Where is tan of theta undefined? It's undefined at the asymptotes. And in this case, the asymptote that we are going to take into consideration is 90 degrees. So we are going to say that x is equal to 90 plus K180. Remember, it's K180 because of the tan function. The period of the tan function is 180 degrees, so therefore our answer is A is equal to 90 plus K180. Let's look at 6.3. 6.3 is a general solution sum. So here, what we are going to... Let's look at 6.3. We have 3 sine squared x is equal to 2 minus 5 sine x. What we want to do is we want to get everything over to the left hand side and the right hand side equal to 0, so that we can factorize the expression. And once we factorize, we see that we get 3 sine x minus 1 times sine x plus 2 is equal to 0. And we have 3 sine x is equal to 1, or sine x is equal to negative 2. Now, sine x is equal to negative 2 will not give us a solution because we know that our values need to lie between 1 and negative 1. So negative 2 will not give us a solution, but 3 sine x is equal to 1 will give us a solution. And so we say 3 sine x is equal to 1, sine x is equal to 1 over 3, and you find your reference angle. Your reference angle is 19,47, and we know that this takes place in the first quadrant or it takes place in the second quadrant because the value of sine is positive. That value there is a third, and that tells you that it will be in the first quadrant or the second quadrant. So what we do is we can take our reference angle and we say 19,47 plus K360. That will give us the value in the first quadrant, and for quadrant 2 we can say 180 minus our reference angle, and that will give us 160,53 plus K360. So those are the two values for that particular sum. So those are the two solutions for that particular sum. Right, let's look at question 7. Now we are getting to sine, cos, and area rule. 7.1 says, write BF in terms of theta and y. So what we see. So let's look at this purple triangle. We see that BF over sine theta, which is that angle there, is equal to y over sine 30. There's y, there's sine 30. All we are going to do is we are going to cross multiply, and we are going to say y sine theta divided by sine of 30 is a half. And when we divide, it gives us 2y sine theta. So BF is equal to 2y sine theta. Now, in 7.2, they ask us to write DF. They ask us to write DF in terms of alpha and x. So we are looking at, so now we are looking at the blue triangle, and we are going to say DF divided by sine alpha is equal to x divided by sine 30, and cross multiply again, and we see that x sine alpha divided by a half is going to be equal to 2x sine alpha. Now they ask us to find BD squared. It says hence prove that BD squared is equal to 4x squared sine squared alpha plus 4y squared sine squared alpha. But we see that BD, triangle BDF, is a right angled triangle. And so we can say that BD squared is equal to 2x sine alpha squared plus 2y sine alpha squared, which gives me 4x squared sine squared alpha plus 4y squared sine squared alpha. But in 7.4, they ask you to prove that x is equal to the square root of 4y squared sine squared theta divided by 7 minus 4 sine squared alpha. Now, what you see here is a value that you have for BD squared. But what we can also do is work out BD squared using Pythagoras in the big triangle here, CBD. And we see that we can say 4x squared minus 3x squared, that's 16x squared minus 9x squared, which gives me 7x squared. And what I'm going to do with that 7x squared is I'm going to equate it to the value we got here, which is 4x squared sine squared alpha plus 4y squared sine squared theta. What I need to do now is take the x squared the 4x squared sine squared alpha, I need to take it over to the left hand side. Why? Because I can see that there's a possibility of me taking out a common factor. So if I take out the x squared, I'm left with 7 minus 4 sine squared alpha, and I can divide by that to get x squared is equal to 4 y squared sine squared alpha sine squared theta divided by 7 minus 4 sine squared alpha. And I need to find the square root of that. And I need to find the square root of that. So x is equal to the square root of 4 y squared sine squared theta divided by 7 minus 4 sine squared alpha. Thank you so much for watching. That's the end of our trigs video. Please make sure that you study hard, guys. I know that it's exam time and it's difficult and it's stressful, but take it one step at a time, just one day at a time. That's all you need to do. Make sure that you revise regularly and practice. So that's the end of our video, guys. Please don't forget to share, subscribe, comment on our videos. I'd love to hear from you. Keep well, and I hope to see you again soon.